Welcome to the Explainer. Today, we're tackling something absolutely huge. We are building the ultimate master blueprint for crafting the perfect 2026 coding lesson. We aren't just going to sit here and talk about code today. We're actually going to reverse engineer exactly how to teach it, how to record it without spending hours pulling your hair out in editing, and most importantly, how to make sure your students actually remember what you say.
So let's kick things off with a pretty tough question straight from our Snapify source material. Picture this. What do you do when half your class grasps a new programming concept immediately, but the other half feels completely lost? It is a super high-stakes teaching scenario, right? Because we all know those one-size-fits-all lectures, well, they just don't work anymore. If you move too fast, you lose people. If you just show them dry code without any real-world application, they just tune out. We really need a solid strategy to bridge that gap.
Section 1. The hook. The digital filing cabinet. Just look at the contrast here. On one side, we have the traditional, honestly kind of boring way to explain memory allocation. You know, the kind of textbook definition that puts beginners right to sleep. But then, on the other side, we have a highly visual, real-world analogy. Our goal right out of the gate is to tell the viewer, hey, today we aren't just writing code. We are learning how to organize information so our programs can actually remember things. And I love this because it brilliantly illustrates the whole concept. We define a computer's memory as this massive room just totally full of empty drawers, basically a giant filing cabinet. So what is a variable? Well, it's literally just a label you stick onto one of those drawers so you can find and use the information inside it later. Just like that, the abstract idea of a variable becomes a tangible physical action that anyone can picture. Let's ground this with a practical scenario we all interact with daily. Think about a standard login screen. Behind the scenes, in the code, there's a variable called username. Now, when user A types their name, our username drawer holds the data for user A. But then when user B logs in, that exact same drawer now holds user B. The key insight here is that the field, the variable itself, stays exactly the same, but the data inside it changes. And honestly, that is precisely why we call it a variable. Moving right along to Section 2. Avoiding cognitive overload, breaking down data types. Now, to keep our learners from getting overwhelmed, we have to explain that in languages like C++, we've got to tell the computer what kind of information actually fits into the drawer. Think of it as defining the shape of the drawer. We break down the most common types really simply. A string is for text, like our username. An int is for whole numbers, like a follower count. A bool is just true or false, answering questions like, is the user logged in? And a float or double? That's for decimals, like an account balance. By attaching each of these data types to a real-world social media or banking app feature, the concept just clicks instantly. All right, let's jump into Section 3. Flawless screencast production, the technical execution. Okay, this number right here is absolutely critical. 1/3. According to FreeCodeCamp, almost a third of viewers are watching coding explainers on their mobile phones. That one statistic should directly dictate your entire visual setup. Think about it. If your text is tiny, you have literally already lost a massive chunk of your audience before you even start explaining the code. Because of that, your live coding workflow has to adapt. First things first, bump up that font size in VS Code significantly. Seriously, make it big. Second, type your code declarations live on screen. And as an instructor, remember to speak energetically. Imagine you're talking directly to just one person sitting right next to you. Finally, we use an on-screen tool like Turning Shot to highlight the syntax as we speak. And this is where it gets really fun and interactive without ever having to open a video editor. While you're recording live, you use Turning Shot. You hit Ctrl+X to draw a bright box right around your string declaration, and you label it the drawer type. Then you circle the variable name and label it the drawer label. You can even hit Ctrl+A to manually zoom in super tight on the semicolon, just to remind viewers that it accessed the period ending our instruction to the computer. It brings this incredible dynamic energy to the screen. Now, to pull this off and eliminate post-editing glitches, we use a strict pre-production checklist. Keep your mic about 4 to 8 inches from your mouth, and here's a great trick. Put a simple towel under your keyboard to mute those loud, clacking typing noises. Next, go into VS Code and set your cursor to non-blinking. That way, if you ever do need to cut a frame, there's no weird visual jump. And finally, use that focus highlight feature to dim the rest of the screen, which basically forces the viewer's eyes exactly where you want them. I absolutely love how Dave Lee from the dev community summed this up. He said the best edit is the one you never have to make. And it's so true. By handling your zooming and your drawing live at the system level, your recording is essentially your final product. You're going to save yourself hours of scrubbing through timelines. Next up is Section 4, Fostering Problem-Solving Skills, Handling Logic Leaks. Here is a pedagogical secret weapon. During your live demonstration, you intentionally make a mistake. Try to store a string of text inside an integer variable. For instance, type out int age equals 20, but spell the word 20 out in letters. Immediately, VS Code is going to throw a red squiggly line at you. The magic here is entirely in how you react to this. Do not edit this out. You use it to teach a debugging mindset. You show them how to actually read the compiler error message. You normalize their confusion. You explain that the compiler is actually protecting the program from what we call a logic leak. And you show them how to isolate the broken line. Leaving mistakes in teaches your viewers that struggling isn't failing. It's just a normal, necessary part of real-world troubleshooting. And finally, Section 5, Project-Based Learning Goals, the Resolution. As we wrap up the lesson, we drop the LogicLadder Milestone Challenge. You look right at the camera and challenge the viewer to build their very own filing cabinet in code. Ask them to declare 3 variables, their name, their age, and a Boolean for whether they are currently a student. It forces them to apply strings, ints, and bools immediately, which builds that absolutely essential muscle memory. And let's look at the why behind all of this. According to the AmQuest roadmap, this developer journey scales incredibly fast. Month 1 is all about mastering fundamentals, like our filing cabinet milestone. Fast forward to month 6, they're containerizing apps and working with cloud integration. And by month 12, having that solid foundation and a portfolio of projects is exactly what positions them to achieve that target entry-level salary of 10 to 15 lakhs per annum. So we've covered the pedagogy, the visual hooks, the zero-edit production secrets, and those crucial project-based milestones. The whole shebang. So here is the final question you have to ask yourself right now. Are you ready to build your own master explainer and start shaping the developers of tomorrow? Grab your mic, set up your digital filing cabinet, and let's get out there and start recording.